In this video we'll show you how we can machine the sloping face on the imported file. So this is the part here, and what we need to do is machine the sloping face along the top. So the first thing I'm going to do is set up my 0 position. So I go into milling, set origin, and I'm going to set the 0 as the middle of the part in X and Y and the maximum in Z. Okay, so to machine that we'll use a pocketing command, and what we'll need is two sketches, one which represents the outside wall of the upstand and another sketch which represents the inside of the bore. So to do that we'll right click the mouse and say pick faces, and then highlight the top face, right click the mouse and say make a sketch from the face. So now in the objects window over here I've now got an entry which is sketch 1, which is made up of the sketches that it's found from that top face. So there's 5 of those, so we just need to get rid of the ones we don't need. So to do that we right click the highlighted sketch 1 and say split the sketch down into its individual elements, and sketch 6 is the one we want to keep, so we can just highlight the others using the control key, and we can delete those sketches. So we're just left with the sketch which represents that top part of the upstand. Now if we just rotate the model round, then we can do the same thing and make a sketch from the bottom face, and that will give us the sketches that go to make up that. But again, the only one I want is that center one there. So if I split the sketches down into them, and obviously there's a lot of sketches there because of all the text here, so I'll just need to identify the sketch that we want to keep, which is sketch number 9, so then I can get rid of the rest. Right click and say delete. So we've just got the 2 sketches there, which is all we need for that. So to machine that as a pocket, we have an outside and an inside shape, so we combine those sketches. So highlight them both, right click and say combine sketches into a single element, which we can use with a pocketing command. We'll set up the tool that we want to use. So under the milling tab we go to tool, and we want to select a ball nose cutter, and it's going to be 8mm diameter. Okay, so that's the tool we're going to use to machine that top face. So because we're going to be projecting the tool path down onto a surface, we need to create the surface. So we use surface, it's found one solid, and the tolerance is 0.1, which is fine for what we want to do here. If we make it any smaller, it would just make a huge program. So we've created the surface, and now on this sketch, if I right click and say I want a pocketing operation, I'll set the step over to a large amount just so that we can check that it's doing exactly what we want. We need the tool to produce a tool path including the tool radius. So if we make the sketches minus 4.1, so that's going to be 0.1 over the boundary of the part, so that'll make the outside 4.1 bigger and the inside 4.1 smaller. So that'll make sure that the tool cleans up exactly over the edges. We're going to select a surface. The tool we're going to use will be the 8mm ball nose that we've just created. The clearance plane is 3. The clearance plane is 50. The feed change plane is 3, and the depth will be a minus value, just large enough for it to machine onto the surface. So we can set that to whatever we want really, but it'll only machine down onto the surface. So if we click OK, then that's produced the tool path exactly as we want it to do, but obviously the step over is too big. if you set the step over very small and have an error somewhere else, then it'll just take longer to calculate. So keep the step over large to start with until you're happy that the toolpath is exactly what you want. Then you can simply go back into the command and change the step over to the value that you want. So that's going to now be recalculating that toolpath. So that's the toolpath that we've created there, which all looks good. So we'd probably need to find out how big those two parts are so that we can create the stock material for us. So if we just go into geometry, and I just need to know roughly what size that is. Okay, so that's 31 and the outside is about 40. Okay, so I just need a rough value for those two dimensions. I could read them from the drawing if we had one available. Okay, so we can now save that away. Okay, so now we can go into milling. We can go into the setup tab here and make sure that our feed change, tool change position is what we want it to be, and the post processor that we want to use. So now we'll simulate that. So that's creating the simulated data, and now it calls up the simulator and we'll set up a piece of stock which represents the two radius values there. So if we didn't do anything else, it would give us a square piece of stock, which was slightly bigger than the part, but we can change our stock so that we can define exact sizes. So we can have bar stock, the OD can be 40 and the ID can be 31, and the length of those is 20. So that just gives us a piece of stock which represents the tube part of the component, and then we can just see the tool simulating on top of that. Okay, so that's the part, 40 on the outside, 31 on the inside, and now we can just replay that tool path. So that's using the 0.25 step over that we specified. If we need a smaller step over, then we can set it. 0.25mm will give us a good surface finish that might need just a wee bit of hand finishing. But if you don't want to do that, then set the step over to something like 0.15mm. It will produce a longer program, but it'll give you a finer finish. Okay, so that's that part. Let's go back into the program. Now the only other thing that we might want to do is, depending on the material and the tool type, we may not be able to machine that in a single pass in the Z-axis. So if we want to change anything there, we go back into the pocketing command and we'll set the step down to a value. Again, this will depend on the material and the tool that you're using. Well, that's going to recalculate the tool path, which will take a minute or so. Okay, so that's created another tool path, and in this instance we've cut down 2.5mm, and you can set that to a smaller value if you need to. Okay, so that's how we do that. The last thing will just be to post-process that for your particular machine tool.